Good morning, Scott here, known as Cantaloupe to some online, and I'm bringing a video to you on a subject that's interesting to me. It might be of interest to you or someone you know, and I'm going to discuss the formula of the sphere. I have gotten away from geometry and programming in some of my videos lately, and I want to get back to it just a little bit. So I'm going to talk about something that's fairly straightforward, pretty simple, and I have a great deal of experience with, so I hopefully can shed some light on the idea if you're into programming and graphics. If not, this might not be a video for you, but this one is very helpful. It would have been helpful to me when I was learning, but I had to figure it out myself. So let me talk about what I did figure out myself. There's a very simple formula. It's pretty well known, actually, and it's not hard to look up, but describing it this way might make it easier for somebody to understand, and I'm going to show you how I do it on the screen with my language here is JavaScript. It's browser-based code that can render graphics in the HTML5 graphics API, the Canvas API. And so what I'm doing is I'm going to use sine and cosine, and the sine cosine functions that are built into pretty much every programming language that I've seen are very handy for rendering graphics. You can do rotations, you can plot a circle, obviously, and they derive from the angles or the lengths of the triangle. Ultimately, if you look back at geometry, if you took geometry, or if you want to review and look it up, you can see what they mean specifically. And I'm not going to dive too much into trigonometry or geometric theory in this video, but I am going to describe the formula of the sphere. So I use sine and cosine to basically plot a circle. It's pretty straightforward. If you have x and y bound to sine and cosine respectively, and you increment the angle that you're feeding into both of those functions, and it stays the same for each one per plot point that you're drawing, it plots out a circle. And it might be obvious. It was not obvious to me initially, so I'm kind of going over some stuff that might be review for some people. But so a circle is pretty easy. So how do you turn a circle into a sphere in 3 dimensions using only sine and cosine? So what I'm going to do is I'm going to add a second component to the x and the z dimensions. So I still have the sine and cosine for x and y, but I've added another variable. Notice my angle is described by the variable p for the circle, and I'm adding sine and cosine for x and z, multiplying, I should say, not adding, but multiplying by q. I'm adding another angle called q. So there's sine p multiplied by sine q for x. Y is just going to stay, is actually cosine q, and then z is cosine p times sine q. So what this does, and what I'm doing is, if you look at the structure of this, comparing it to the circle that was being drawn just a moment ago, it's basically drawing a circle, but you're modulating the radius of it along the axis of z. So you're getting a sphere out of it, and it turns out if you just multiply each one of these dimensions, these components, x, y, and z, by another number, you can control the radius of the sphere. And it kind of is that straightforward. So hopefully that makes sense in the context of what you saw me do here, and the final sphere is pretty evident, self-evident. So if you have any questions, please feel free to reach out to whitehotrobot@gmail.com or comment below. Thank you.